Hey, thanks for watching. This is Josh with some more practical math. Today I wanted to go over solving equations with variables on both sides. They can get a little bit crazy, so I thought I'd give you 5 examples here. I always encourage you, if you want to watch the first one and then kind of double back and pause the video, try all these yourself, see what you get. Let's check our answers together at the end and then move forward, okay? I really think that that's a great way to learn these types of problems. So let's just jump right in. I'm gonna rewrite them over here as we go. We got 3y minus 20 equals 8y, okay? Our main goal for all of these problems is to do something that I've written up here 1,000 times, is to get all your variables on one side and your numbers on the other. It doesn't matter what side you get them on, but you gotta work in this manner. I think it's very efficient. I think it's practical. I think it ties right into this other stuff that I've been teaching as well. It's a great skill to have, and you're gonna need it for a long time. So, at least if you're sticking with math past this. Variables on one side, and I always just draw an X on the board with students because I think that just kind of hopefully helps to remind them what is the goal of this thing? Like, why am I even doing this? I guess that could get philosophical as well, but anyways, X's on one side, numbers on the other, okay? And it doesn't matter if your numbers are on this side and X's are over here. I just write that on the board because I feel like it reminds me, oh, okay, that's what I'm working on, all right? So I got variables and numbers on this side and variables over here. So I guess the easiest, I don't know, I think it might be the easiest, would be to just get rid of this guy, okay? Now it's important as you do these to pay attention to the things that are in front of these values, because that's really going to tell you what to do. And if you've watched my other videos on solving for X, this is just kind of taking it to the next step because there's a little bit more stuff going on. Oops, but it's pretty much the same thing, okay? And so I have a 3y minus 20 equals 8y. In order for me to get rid of that, I need to do the opposite. So I subtract 3 y's and get a 0. What I do to one side of the equation, I do to the other. 8 y's minus 3 y's is 5 y's. This thing just kind of drops on down, okay? But this is where I was saying you gotta be careful because there's a lot of stuff in there that's important. Mainly this negative sign, negative 20. If you don't bring the negative, your answer is going to be wrong, okay? Because you need it. This is 5 times y, right? So I do the opposite and I divide by 5. What you do to one side, you got to do to the other. We read our fractions down. You'll notice in my other videos, I always draw those arrows. It reminds me what to do. Negative 20 divided by 5 is negative 4. So that would be my final answer. Now, you probably should rewrite it, meaning turning this thing around. Y equals negative 4. I think it's a cleaner way to write your answer. Shows that you understand what's going on. And you can plug that in right here for y to check your work and plug it in over here. I'm gonna do that quickly. It's not the focus of the topic, just to like check your answers, but you know, we'll check it along the way. Negative 4 times 3, let's do it over here. Negative 12 minus 20 equals 8 times negative 4 is negative 32, okay? Does negative 12 minus 20, okay? Again, that's a weird concept, you know? Let me just draw it here. I'm at negative 12, okay? Remember, this is my x-axis or my number line. This is my negative direction. So if I start at negative 12 right here and I go negative 20 from that, right? I'm going to go back 20 more spots, negative. I'm going to end up at negative 32. So it does work. And you should check your answers. On stuff like this, I always recommend check your work, right? Like, why would you turn in a test like wondering how you did when you have your answer? Plug it back into this equation and see what you get. Okay, so if you feel like you're getting the hang of it, pause the video, take a look at the next one, see what you get, and then come back to me and tell me how you did. Well, I can't really hear, but you know, talk it through, okay? It's worthwhile. 2a plus 6 equals negative a minus 8. All right, that thing I gotta do, x's and numbers, right? Every single time. Okay, I got both on both sides, so it doesn't really matter which direction you go. You're gonna get the right answer as long as you follow the rules of math. And so, what should I do here? I'll move this guy again, okay? Just because it will give me something interesting here. So it's positive 2a's, right? If it was a negative 2a's, there would be a negative sign. But because there's no negative sign, I know it's a positive 2. So I subtract 2a's from this side, get it down to 0, and I subtract 2a's from this side. A negative a, again, this is kind of like that first problem. I know it looks weird, but a negative 1a, and if I'm going in the negative direction, 2 more, right? Because it's negative a, that's my starting point, minus 2a's, minus 2 more a's is gonna put me at negative 3a's. And I hope you're not saying, yeah, dude, but Josh, like, what's going on? Now I have a negative 3a answer. Is that even gonna work? Well, let's find out. The rest of this stuff, I'm just gonna drop down to this level so that I can work with it. And then this guy here. I'm not gonna write the plus sign because it's just a positive 6. Okay, I'm getting there, right? X is on one side, numbers on the other. I got my number, X is all on one side, or my variables. Got to get rid of this guy. It's a minus 8, so I do the opposite, and I plus 8. I know that's not the technical way to say it. I could say I add 8, right? And what you do to one side, you got to do to the other, okay? 6 plus 8, if you're not good with numbers, that's okay. 8, 9, 10, 11, 12, 13, 14, all right? So that's a 14. Don't give me guff for counting on my fingers. There's all this new research that says that that's a great way to count because it's using kinesthetic motion along with saying things, and so it's a great way to learn. At least that's the newest research. Things might change next week. Okay, and so now I need to isolate my variable. Negative 3 times a, divide by negative 3. What you do to one side, you do to the other. We read our fractions down. I'm writing the same symbols on every single problem because that's what's going to help me be successful and get these things right, right? That's the main goal of this whole thing. That's why you're watching these videos. These guys cancel, so I get a equals 14 divided by negative 3. It's a decimal. 14 divided by negative 3 is 4.6666, repeating. So I'll just leave it as a fraction, I guess. Negative 4 2/3, okay? I guess that looks a little bit cleaner. I'm always bummed when answers are like that, on a side note, just because the goal of this is for you to be figuring out like all of this and this and this. Okay, when the answers start becoming, you know, decimals like that, repeating decimals, it makes it harder to like check your work because you're just barely learning how to do this. And now I'm asking you to put in these decimals that are repeating. It doesn't work out that pretty, in my opinion. I don't like it necessarily when books do that to you because, again, you're learning the basics of this stuff. This is not, well, let's throw in some repeating decimals and numbers that aren't even gonna maybe work with this thing as cleanly as like a 7 or a negative 2, right? But that's just my personal opinion. I don't write the books. I'm just here to help you get through all of this stuff. All right, let's move on to the next guy here. And I chose these problems because if you notice, each one is just a little bit different with the things that you need to do, but they're all very good skills to have. All right, what's the thing I gotta do up top? You got it. X is on one side, numbers on the other, okay? It's just gonna remind me what I'm doing with these things. Okay, well, 3x, that's kind of done. This guy, I got to multiply this times this, which means I need to use that distributive property like that. So 2 times x gives me 2x. 2 times negative 4 gives me negative 8. And there we go. Okay, I need to isolate my variables and get my variables to one side, my numbers to the other. So because my number is on this side, I'm going to move this guy over. Negative 2x, right? I do the opposite. Gives me a 0. Negative 2x. So I end up with negative 8 equals 3x's minus 2x's is 1x, or just x. Nice thing is, I'm done with this problem because I've already gotten it down to 1 unit of x. As you get better at these, you know, like in the beginning, if you want to write a 1x to remind yourself that it's just 1 unit of x, you can. You could even put a 1 there. It's not wrong, but I'm sure teachers will start to say, okay, well, you're kind of moving up in math. You probably don't need the 1 there anymore, because if there's no 1, we just assume that it was 1 unit of x. This one's a little bit cleaner. Could I write this value in right here, check my work on this side, or multiply out, and then multiply this 3 by a negative 8. Check the answers should be the same. Yes, I'm all set. Okay. I hope this pace is not too fast. You should be aware of like what I'm doing with that distribution rule and, you know, the whole like division to isolate the number at the end. I have other videos. If that's still confusing, go back and watch those and then kind of catch back up to this stuff. The reason I'm going faster through those is because that would be something you've already learned, and now you're starting to really apply these tools to more complex problems like these. So we did this guy, this guy, this guy. Let's do this guy with a fraction. 1/2 4x minus 2 equals x plus 5. I'm just going to kind of make a squiggly there so it blocks that thing out. As always, x is on one side, numbers on the other. That's what's going to remind me of what to do. I got to distribute this 1/2, which really just means you're cutting both of these in half. So 1/2 of 4 is 2. Half of negative 2 is 1. X plus 5. Once you're to here, like I said, it doesn't matter what side the x's are on. So if you're starting to get more comfortable with this, I would say look for the easy route out. And in this situation, I had 2 x's over here and 1 x over here. If I subtract 1x from this side and subtract 1x from this side, I guess I could put a 1 in there, I end up with 1 unit of x that's left in the equation. If I were to subtract 2 x's from this side and subtract 2 x's from this side, now I have a negative x, and it just requires you to do 1 extra step. It's not that bad. But if you're starting to get better at this or more confident, I would look for these ways that you can kind of keep everything positive. Okay, so when you subtract the x value from this side and this side, or I'm sorry, the 1 unit, then this doesn't become a negative value. So I'm just going to rewrite it. These just kind of drop down to the next level. Okay, make sure you bring the negative. And then from there, x is on one side, numbers on the other, so I got to get rid of this guy. Plus 1, and what you do to one side, you do to the other. So x equals 6. Okay? Let me do that last part as I was talking about it. Okay? Yeah, let me erase this and this. I guess I'll do some of that too. Oh, that's not pretty. Whatever, right? It's mainly to prove a point. Let's say I didn't know that whole thing about what's easier, and I just said, you know what, I always do the left. Minus 2x, minus 2x. This is 0, so I have negative 1 equals x minus 2x is negative 1x plus 5. I know I don't need the 1 there, but I'm going to leave it there anyway. And now I got to get my numbers over here, so I subtract 5, and I subtract 5. Negative 1 minus 5 is negative 6. And I have a negative 1x, okay? Now I don't care what negative 1x equals, okay? Just like I don't care about like what is 2/3 of x equal, okay? That's not the point. The point is to figure out what x equals. You want x equals and then an answer. So the quickest way, most efficient way to get rid of that negative 1 there is to multiply this side by negative 1, because negative 1 times negative 1 is positive 1, right? A negative times a negative is positive. What you do to this side, you can do to this side as well. Negative 1 times negative 6 is positive 6. And you don't need to write the positive sign. I'm just doing it to kind of accentuate what's going on. Rewrite it in a cleaner fashion. X equals 6. Bam. Done. We already got 6, so I know it worked, but I just wanted to go this route to show you what's going on. Now, I guess the question could be, well, hey dude, could I do the numbers first and then do my x's? Yes, you can. Follow the same rules, move your numbers to one side first, then move all of your x's. I don't know, I guess for some reason I like to work with the x's first and then do numbers second. It's personal preference. Most books that I've used don't really tell you which one to use first. And as you get better at this, finding these quicker little methods might save you some time. It's not like it's more difficult just because you have negative values. It's just that you have to remember one extra step, which is definitely helpful. But if you can do it with less steps, at least when I teach it, my goal is if I can teach it with less steps, then I'm hoping that you will have less ways you can get it wrong. So let me erase this guy and we'll move on to that last one. I'm gonna leave this up there now just because I'm writing it every single time and not really necessary at this point because we know what's gonna happen, but I'll leave it up there as just a reminder. 2y minus 0.3 equals, what's that, 19.4 minus y. Okay, this looks a little crazy. 3 times 2y is 6y. 3 times 0.3, if you're not sure, use your calculator, okay? Oh, it's a negative 0.3. So 0.3, or negative 0.3, times 3 is 0.9, okay? Negative 0.9, I should say, or 0.9. A lot of times books put the 0 there just to show you that it's 0.3, because when they're typing out the work in the book, it might look like it's the end of a sentence. It might, as a period, it might look like it's a multiply, because later on you'll see a dot as multiplying rather than an asterisk or something, or just the X. And so a lot of times when there's decimals and it's just in that first position, they'll put the 0 there as a filler to remind you that it is a decimal, negative 0.3, or negative 3/10. I guess you could say it that way as well. Some books like you to say it out loud so that you know what you're working with. Okay. Like I said, I like to do my x's or y's or whatever first. Because this is already just minus 1 unit of y, I think it would be quick for me to add 1 unit of y and add 1 unit of y. 6 y's plus another y is 7 y's minus 0.9 equals 19.4. And now I need to get rid of this guy, so I will add 0.9 and add 0.9. I'm using this calculator a lot actually today. 19.4 plus 0.9 is 20.3. So 7y equals 20.3. Now 7 times 3 is 21, so I know this answer is going to be some decimal. So y equals, just a reminder, 7 times y means I would divide this side by 7 and divide this side by 7. 20.3 divided by 7 is 2.9. 2.9. Okay, so that would be my final answer. Could I plug it in here and here? Yes, I could. And that would be how I would check this problem. I would put it in here, combine these two, multiply it times 3 and get some number. Then I would take 19.4, subtract 2.9 and get the same number, I'm assuming, okay? If this side balances or equals this side, then we know we have the correct answer down here, okay? So if you still have questions, post them for me. Go through these again. These are great examples because you got some distributive stuff here, you got fractions, you got decimals, you got some basics here even with negatives on one side. Practice them over and over, okay? This is really good stuff to know for your math journey. Thanks for watching again. Check out my other videos.